Hello, everyone, and welcome to today's webinar, Tapping into Pollution Prevention, Energy Efficiency Challenges at Craft Breweries. Before we get started, I want to give a shout out to Dan Roberts and the Alabama Brewers Guild. You know, when UA SafeState first started planning these trainings, our goal was to host this event in person, but as COVID shutdowns began, Dan and our team worked hard to put these targeted webinars and training series together and offer it free and in a virtual setting. So thanks, Dan. And thanks to the Alabama Brewers Guild members in attendance today. UA SafeState is happy to be the host of today's program. My name is Ashley Chambers, and I'm the Environmental Services Manager at UA SafeState. Also on the line today is Michael Raspberry, our Associate Director at SafeState. UA SafeState is part of the College of Continuing Studies at the University of Alabama. It consists of environmental and occupational health and safety consultation programs and training. UA SafeState was recently named the state contact for pollution prevention with the goal to provide local businesses with technical assistance and training to find ways to reduce waste and save money. Our team would like to thank the EPA Pollution Prevention Grant Program that helps fund our P2 program and gives us the opportunity to provide important training just like today's webinar. For those listening live, I want to wish all of you a very happy Pollution Prevention Week. So to begin this morning, Scott Thurston is on the line. He is with ABS Commercial. In conjunction with the Alabama Brewers Guild, he helped to facilitate this webinar and bring many of our attendees here today. Scott, if you would, please share a few words about ABS and an exciting opportunity for the brewers on the line.
Thank you, Ashley, and thanks everybody for being here this morning. Got a couple things going on. First, a little bit about ABS Commercial. We've been in business since 2012 and sell brewing equipment across the U.S. Have some over at Brewdog in Scotland, a little bit in Mexico, some in Canada. So we've been around for a while. We actually use the same equipment that we sell at our 20-barrel brewery here in Raleigh, North Carolina. And if you're ever in town, always invite you out here to come out. We'll show you the facility, have a couple beers. Also wanted to mention that we've got several customers in Alabama that if you want to stop by, I'm sure they wouldn't mind showing you the equipment, or hopefully they won't. Back 40, Black Warrior, Ghost Train, Red Hills, which is now Grocery Pub, just to name a few. They're customers of ours in Alabama. As far as if you look at my background here, you'll see that we are giving away a keg washer on December 12th. We did this in the spring and had great response, so we decided to do it again, especially nowadays. That's a $10,000 keg washer that we're giving away. Basically, just go out to our website there and sign up for it. If you go underneath equipment and look for the keg Viking or keg washer, you'll find the entry form out there. One other thing that we're doing, if you were on here yesterday, you'll be included too. Anybody that's attended this meeting today or yesterday will be entered into a contest. We're giving away a $250 gift card for small parts for fittings and stuff like that. So at the end of the contest, or at the end of the meeting, Ashley's going to give me the information, and I'll have our marketing guy draw somebody's name out of that. And then Dan, I already spoke to Dan, he will go ahead and announce the winner in the next week or so, I think. So anyways, I appreciate you guys having me here, and look forward to helping Alabama craft beer grow. And if you need anything, please give me a call or just shoot me an email. Thanks, Ashley.
Oh, Scott, that's great information. And also good luck to all the local brewers who could win a gift card and some free equipment. That is wonderful stuff. And we appreciate ABS as well as the Brewers Guild for bringing us together today. So before I hand it over to our speaker, there are a couple of housekeeping items to cover about this presentation and the platform we are using today. We're using Zoom. And to reduce background noise, don't worry, all attendees, except for our speakers, have been muted and your video camera is disabled. But if you do have a question for our speaker, please send it through the chat feature and we'll be answering those questions at the conclusion of the webinar. If we don't get to your question, don't worry, we'll follow up with you afterwards. As a reminder, today's webinar will be recorded and made available soon. So without any further ado, I am so pleased to introduce today's speaker, Dr. David MacPhee. Dr. MacPhee is at the University of Alabama's College of Engineering, an active faculty member who instructs many students each semester. His research is broadly focused on energy efficiency, energy conversion, and computational mechanics. He also spends a good bit of time in the field, like this week, right, Dr. David, supporting businesses with their energy efficiency. He's also the Associate Director at the Alabama Industrial Assessment Center. So Dr. MacPhee, if you will please share your screen with everyone, I will stop sharing mine and I will let you take it away. Thank you again.
Thank you very much, Ashley. Hey everyone, I'm gonna share my screen. I promise I'm able to do this. I will continue share my presentation, and hopefully you all can see. If not, yell at me or something. I'm gonna start the slideshow. You know, I probably should have had this done beforehand, but don't worry. That's the only thing that'll go wrong here. I'm sure of it.
That looks great. It looks
okay.
perfect, Dave.
Excellent. Okay. Thank you for having me. And I'm really sorry I couldn't be there for yesterday's presentation. I was doing something. I think I was teaching a class. They make me teach. I'm an assistant professor here at the University of Alabama, so they do require me to teach classes from time to time. So, Jim, I'm sorry I forgot. I didn't see your presentation. And I just want to first of all just thank everybody for having me here. There's a lot. It's a really busy title slide. The most important, obviously, is the picture of the beer. But I am, as I said, I'm a professor here in mechanical engineering at UA, and I'm also funded by a variety of other mechanisms. Hopefully you can see my cursor here because I'm going to be using it a bit. But the Industrial Assessment Center is something I'll be talking about quite a bit. It's a Department of Energy funded program devoted to increasing efficiency for manufacturers, and breweries fall under that category. UA SafeState, which Michael and Ashley are part of, and thanks for having me, and give a shout out to you all. And on the bottom here, we've got U.S. Department of Agriculture on the Rural Development Program. Please, if I forget to mention U.S. Department of Agriculture and their grant program, please ask me about after the webinar. There are ways for you to, in some cases, save large amounts of money on energy efficiency projects. Without further ado, I'm going to set my timer here so I don't go over 50 minutes. I only have, I think, 25 slides, but I am a professor and I will talk forever. So we're going to try and keep this short. Anyway, today's topics, we'll be talking about the IAC and AREP programs. Obviously, I run some programs here through the University of Alabama's mechanical engineering program. I gotta talk about them a little bit. Maybe you can use them, maybe not. We'll find out. Then we'll talk about brewery energy usage, and by energy I mean electricity and natural gas. And so we'll talk about ways to conserve electricity and natural gas, and possibly to if you reduce consumption, you can reduce costs, increase profits, reduce emissions. Everybody wins. And so at the end, a Q&A. Hopefully we'll have a lively discussion of all the things I'm going to cover. There's an incredible amount of information to cover in the next 40 minutes, so I will keep going on here. As I promised, I'm going to plug two programs that I run here. The first is the Industrial Assessment Center. This is a really busy slide, but I'm really just letting you know that there are things called the IACs, and they are located at universities throughout the United States. There are 28 of these centers located at universities across the country. I think I've got a circle here showing you that, the big elephant in the room, University of Alabama is right there. And there are centers at Georgia Tech, Tennessee Tech, LSU. And what do these centers do? Well, they are funded by Department of Energy, your Department of Energy. And the main goal of these centers is twofold. One is to help small to medium-sized manufacturers save on energy and help them remain cost competitive. Excuse me. And the second is to train the engineers of tomorrow to be energy savvy. So currently we have, I'm going to say 8 or 9 undergraduates and 3 or 4 graduate students working in our Industrial Assessment Center here at UA. we're going out to manufacturing facilities. I went to one this week. They're producing plastic pellets. We do all kinds of interesting stuff. It's been a while since I've been to a brewery. I think I went to the Miller Lite Brewery. I know, large manufacturer out in San Diego, Los Angeles County, a long time ago. I digress. So we want to help the small to medium-sized manufacturers stay cost competitive and increase their profits, and also help engineers become better energy savvy engineers. And so let's just keep going here. This is our UA IAC. This is information you can get off the iac.university website. I'll share a link. I'll share a link for that website at the end of the presentation. But this is kind of our sphere of influence here. You can see we're in Tuscaloosa, and each one of these dots represents an assessment visit that we went on. We go all over Alabama, as you can see. We venture into Mississippi a lot more than Georgia, and we have gone to Arkansas before, but that was awful. It was a long trip. These are one-day trips. We do energy audits on facilities. We do one-day trips. We get in at 8 a.m., so you got to leave pretty early in the morning, and we document energy usage, recommend energy savings practices, and we also give people an idea of how they're using their energy. Give them a pie chart that says, here's what you're using your energy on. We do a very good job of it, and we've been doing it since 2007. I have been here since 2014. The director, Dr. Keith Woodbury, has been doing a great job since 2007. Anyway, I don't want to spend too much time on this, but here's some metrics that we have that you can get off of our website. We've been on 259 plant visits, 1,800-ish assessments, recommended 8.5 tera BTU, that's 10 to the 12 BTU in energy savings, and 47 and change $1 million in cost savings. But I think the most important point here is that our industrial assessment center has trained 118 students that are now out in the wild, being energy savvy and energy conscious engineers. So let me keep going here. Oh, one thing I forgot to mention, maybe the most important thing, our service is 100% free. It's sponsored by Department of Energy, which pays the bills. It pays the salaries of all the staff and our travel and equipment and everything. And so it's sponsored by Department of Energy. So if you think you can take advantage of this, please let me know. If your brewery spends over $100,000 a year on energy costs, which is if you add up all the costs that you spend on natural gas and electricity, add them up. If it's over 100K a year and less than 2.5 million a year, you will qualify. And if you're in Alabama, you can probably waive this 150 miles from IAC. I will make exceptions and go down to Mobile or Dothan if you're a brewery, because I like breweries. And I spent a long time working at the Industrial Assessment Center in San Diego, which hopefully you know is a booming, or at least it was booming when I left. It was a booming craft brewery scene. So I had a good time there, and I'm happy to see that the craft brewery scene in Alabama is taking off as well. It's been nice to be here for that. So kudos to all of you for doing that. I benefit obviously from that. Anyway, there's some pictures here that I've shown you of some students on site. They're looking at blowers. I'm sorry, but this is from 2009. I should have probably gotten a picture from this week, but this is, anyway, they're probably documenting the nameplate information on these motors, which are used for an air blower for whatever reason. Anyway, so our typical assessment, we go on these industrial site visits and we recommend 5 or 10 ways for you to save energy. Usually we get between 10 and 30% of cost savings in our assessment. That's what we recommend. I mean, not everyone's going to bite on every single recommendation we make, but a lot of them are honestly action items for plant managers and those in charge, and they actually listen to our advice and they take action. So yeah, I didn't spend too long on that, thankfully, but that's our Industrial Assessment Center program, which I'm an assistant director for. There's another program that we have in case you're interested in renewable energy implementation advice. We have another small program here funded by Department of Agriculture to do renewables. And if you are interested in how renewables might be able to help your brewery, let me know. I mean, email me. I'll give my email at the end of this. But in order to qualify for this program, again, it's free advice on how to get renewables to help you, be that solar energy for your electricity usage, or perhaps I'm thinking as brewers, maybe bioenergy might be something. You have probably a lot of solid wastes from your mash before it becomes the wort, I guess. I think, I don't know a lot about brewing, just so you know, and that may become apparent to you, but I kind of have an idea. I've brewed in my backyard a few times with friends, not my equipment, their equipment. So I have an idea on how it's done. So just keep that in mind. But anyway, so bioenergy, I mean, you could, if you think that you could use advice on renewables, let me know. Solar energy is becoming an energy source that is going to become something you can't ignore in the near future. It's getting to be incredibly cheap. So let me know if you're a rural small business, which you probably are, or if you're a farmer, you may also qualify, but that doesn't probably affect any of you. Anyway, so my next slide. Okay, so we've gone through, thank you for listening to my promotional materials about the Industrial Assessment Center and the Alabama Rural Energy Program. I've only wasted 10 minutes of your time. Now let's talk about energy usage. I got these two plots here from an EPA document that I pulled up earlier this week. This may not directly describe how you use energy, but I think it's a good starting point. The average relative energy use for brewers, big and small in the United States, apparently is 12 to 22 kilowatt hours per barrel. Thermal is 1.3 to 1.5 therms per barrel. The therm is around 100. Yeah, I think it's around 100 cubic feet of natural gas. So you combine all those, you're in energy costs, or sorry, in energy usage, you're going to be using between 50 to 66 kilowatt hours per barrel of beer that you're selling. If you go by, ballparking how much natural gas costs per therm and how much electricity costs per kilowatt hour, it's going to be, it's not exactly equal, but it's going to be relatively similar in terms of your electricity and your natural gas usage, from what I can tell from what I've pulled up in this. I mean, your specific process may be a little bit different. Electricity usage, there's a pie chart here that shows you what I think your electricity usage will look like, or at least a good idea. Looks like refrigeration is a big user of electricity. These are the vapor compression refrigeration cycles, which are maybe powering chillers, perhaps HVAC in your facility. Packaging, we won't talk too much about that. Compressed air is something that I deal with quite a lot. We'll talk about compressed air. Lighting as well, and the brew house and the boiler house, I'm thinking that has something to do with electric heaters instead of natural gas heaters. Anyway, we'll talk about electricity usage and ways to reduce electricity usage in the coming 15-20 minutes. After that, we'll spend a limited amount of time talking about natural gas usage. Natural gas is it's a fuel, right? You burn it, you get heat out of it. Then there's limited ways to increase your efficiency, and we'll talk about how to do that again after we look at electricity. So before we get into electricity, I think it's worth talking about electricity billing. Okay. If you're a residential user, you look at your home energy use and you look at the bill, you're going to be charged per kilowatt hour. That's a kilowatt hour is a unit of energy. And that's basically what you're charged for as a home user. As a business user, you're going to be charged in one of two ways. The first way is a demand-based schedule. So in this case, and this is more common. So if you look at your electricity bills, you're going to be charged for electricity usage, how much energy you use in kilowatt hours, and your demand in kilowatt. Now this demand thing, I mean, either you know this or you don't. And if you don't know this, I'll try and explain to you. And if you do know this, then hopefully you don't fall asleep in the next 2 minutes while I'm explaining this. But the power company is likely monitoring your energy usage, and they're pinging your meter every 15 minutes, and they're recording the energy used from your meter every 15 minutes. And they do that so that they can monitor the maximum power usage on a 15-minute average interval over the entire month. So let's just say you're using, I don't know, 35 kilowatts on average, you're cruising along, and then you got a big motor that you turn on, and you turn on a bunch of stuff for like 20 minutes. Actually more apt for brewers, let's just say you turn on 100 kilowatt heater, an element in a brew kettle. I just made that name up, but I mean, you're heating up, you got to boil stuff at some point in time. I'm almost sure. You turn this on for a couple minutes and it spikes your demand. Your power company is going to be recording that. And they're going to take the highest value that they record over the entire month. And then they're going to charge you about $5 per kilowatt of that highest value. Not only are they going to do this, but it's likely there's something called a ratchet charge. Here's where things get a little tricky, but at least for Alabama Power, if you, I'm going to try to do this quickly, but so if you have, let's just say 100 kilowatt 1 month, and then the next month, your measured max is like 30 kilowatts, you're going to get charged 90% of the maximum over the last year. Things get pretty complicated. But this is all just to show you, to illustrate the fact that it's really pays for those of you who are managing breweries or any industrial facility to maybe pay more of a closer attention to how you're using power, not just your usage, but your demand. And I've talked a lot, and there's a lot of sub bullets in here, but here's a second bullet here. You can ask your power rep, your Alabama Power, or if you're in the TVA territory, any one of those power companies that gives you power, wherever you are, if you get charged for demand, you can ask your rep for your data, and they'll give you the 15-minute demand data over the course of the entire year. You can take a look at that and see if you're using power relatively uniformly when you're operating, then you're doing a good job. And if you see spikes, you can save potentially thousands of dollars a year by diagnosing when those spikes in power happen, and maybe scheduling turning off equipment and don't turn everything on at the same time. I've talked too much about this already. One more thing. Okay, power factor charges are common. So a power factor is the difference between what the power company sells you. The power company sells you kilovolts at an amperage. So kilovolt amps is different from what they record in kilowatts because of something called a power factor. This isn't an engineering course, so it doesn't matter if you understand what this is. Just check your power bill if you have power factor charges. And if you do, you can install capacitor banks. We can talk about this at length after the presentation. You can install capacitor banks to lower your power factor and again, save thousands of dollars a year on your demand charges. Wow, sorry. I get excited about electricity billing. I know it's an exciting time. So electricity rate structures is, we have the demand-based, and I've already talked for too long about that. The second one is the time of use, where you're charged more money for every kilowatt hour during high demand periods, usually June to September, noon to 7 p.m. when all of Alabama is using air conditioners. And so Alabama Power will charge you more for electricity at that time. I've got one last bullet here. If you're on a time of use rate structure, even a 1 hour operating shift change just for June through September can make a huge difference. We're talking 10% of your electricity bill just by starting at your shift at 5:30 a.m. instead of 6:30 a.m. And a lot of times in the middle of summer, people are willing to do that because it gets pretty hot in the middle of the day. If they can get off an hour earlier, it can be a win-win. I'm going to keep going and talk about electrical energy. I guess that's what I'm here for, is to talk about actual ways to save on energy. And so we're going to talk about electricity and natural gas. As I said, we're going to spend more time on electricity than natural gas. But the topics covered for electrical energy are going to be, in this presentation, We can talk about any electrical energy user that you want after the presentation in the Q&A session, but I'm going to talk about lighting, compressed air, refrigeration, and motors. These are kind of like the low-hanging fruit, so to speak. So in terms of electrical energy, lighting is something that's very simple to comprehend, and it's a very easy way for you all to save on your electricity costs. The first bullet here is, please consider changing all your fixtures. Everything that you use in your facility that makes light, consider changing it to an LED. With the exception of maybe lights that you turn on like once a year. The reason being is that the payback is there for changing to LEDs, and I'm going to go right to the bottom of the slide, but waiting to change is wasting money. Okay, by that I mean if and I understand that if you might just want to say, well, we'll just wait till each of these when the lights burn out, we'll change to LEDs. I understand that you don't want to be wasteful, but wasting one fixture or one bulb is nothing compared to the amount of wasted energy, monetarily speaking, and also the amount of equivalent carbon dioxide emissions that are going to be generated because you're wasting energy. Okay, so you would not believe how much carbon dioxide is emitted because you use electricity. So I'm unfortunately going to be talking about CO2 a little bit in this presentation. I think it's important because we all live on planet Earth and we all should be concerned about climate change. So hopefully you all are concerned about CO2. Also, CO2 is incredibly important to breweries, right? I mean, that's how the yeast make that good stuff that we put in that beer. I believe it's anaerobic digestion of sugars. At least that's what I'm told. I don't know. I just buy it at the store. Anyway, so let's get back to lighting. I tend to often go off the tracks here. So with no one here to keep me on tracks, it doesn't matter. We're going to keep going here. Lighting. If you have fluorescent tubes, those are easy fixes. T5, T8, T12. The T12 are the older, way less efficient. T5s are the more efficient fluorescent tubes. If you have metal halide, high pressure sodium, or other lighting, please consider changing to LEDs, especially if you have incandescent. You know what I'm talking about, those tungsten filament, the old light bulbs. Please change them out as quickly as possible. The lighting industry has come a long way. There are drop-in replacements available that use existing ballast on your fluorescent tubes. So you can just take the bulbs out, put in an LED, and it'll use the existing ballast up there. So you don't even have to worry about it. The payback is very quick. If you spend a couple $1,000s on lights, it'll pay back in, well, I'm going to do an example in a little bit, but it'll pay back very quickly. So hopefully I'm getting through to you in that you gotta consider LED replacements for everything that you can. So other than replacing lights, I mean, other options are to reduce the amount the length of time that you have the lights on. And so ways to do that are motion sensors. Those are occupancy sensors, and those can be in a warehouse, hanging from the ceiling, trying to detect when people are walking around, or forklifts or whatever. But also in offices, I have an occupancy sensor here on my wall. It's a light switch, but there's an occupancy sensor hidden in it. There are very cheap ways of installing occupancy sensors. If you don't have the lights on, you're not paying for them. Photo cells, if you have enough, that's the second point here. Photo cells are cells that sense the amount of light in an area, and if it gets too dark, then the lights goes on. So that's another way to save on energy usage. Skylights, if you have skylights, consider cleaning them. You can get a lot of natural light into a building, and consider timers for your lights as well. So yeah, you can change your bulbs, change your lamps, or you can change how often you burn the lamps to save energy. Here is a very, very quick example, just to let you know that you may not think that lighting amounts to much, but it's a quick and easy way for you to save, I don't know, hundreds of $1,000s a year. This is not the office that I'm talking about, but this is an example that we had at our industrial assessment center. There was an office that had 10 6 bulb T8 fixtures. And so that's, basically what you can see here. It was a very well lit office. They were burning these fixtures 10 hours a day, 300 days a year. And so if you just go through the very simple math involved with that, the energy usage is about 5,760 kilowatt hours per year. And when we got there, that's how much energy they were using to light up that one office. The cost for this was $691 a year. It doesn't seem like that much, at about 12 cents a kilowatt hour. When I'm talking about energy cost for the remainder of this presentation, I'm just going to be using a blended rate, dollars per kilowatt hour, just to make things simpler. Remember, I did talk about the fact that there is a demand charge and a time of use charge, but just to make things simpler, we're gonna just assume that energy costs 10 to 12 cents a kilowatt hour, which is pretty consistent with what you might pay. Here's something that may surprise you. Using these lights for that amount of time per year actually generates, at the point of source, almost 6,000 pounds of carbon dioxide emitted to the atmosphere. Obviously, there's not carbon dioxide coming from the lights in your ceiling, right? But if you trace your electricity back to the electricity generating station, on average, every kilowatt hour is going to be responsible for a certain amount of emissions. And I don't know. I always think that this is it's more than most people think. Just to have an office, a smaller office lit up, 6,000 pounds of CO2 released to the atmosphere, which is exacerbating climate change, yada, yada, yada. We can talk about that more later. But we try to, at least in what I do, is I try to not only identify energy savings, but also let people know that they're saving on emissions as well. Anyway, so going back to this office, yeah, it was well lit, excuse me, and we recommend they replace all their lights with LED drop-in replacements. Okay, so these are plug-and-play replacements, 15 watt, similar lumen output, which is a light power. These things cost $2.99 a bulb, and I accounted for shipping and tax and whatever in this analysis here. But these are really neat, high efficiency bulbs that you can just plug in. And some of these bulbs, I'm not sure if these are the ones, they may be a little bit more expensive, but some of them work with the existing ballast in your fixtures, and some of them can work both with the existing ballast and without. So if the ballast goes out, you can actually rip it out and directly wire to the lighting system if you're savvy with messing around with the wires up there. Anyway, so if you replace with these 15 watt replacements, you had 32 watt to begin with. Now you're going to 15 watt. You're going to save about half the energy, and so this is about half the energy usage, half of the cost of $360 a year, and 3,000 pounds per year in terms of CO2 savings. Simple payback for this project was 7 months. Okay, so that's just one example. Not every lighting project is this cut and dry, but in general, if you turn the lights on every time that you're in a facility for at least a couple hours, you should immediately think about changing those out to LEDs. I'm going to stop talking about LEDs and start talking now about compressed air. I have an idea based on a pie chart that I showed you earlier that you might use compressed air in a brewery, and I am not entirely sure for craft brewers what the extent of that compressed air usage will be. Whoops, sorry. I hit from current slide. I don't know why, but I hit escape there. Hopefully you can still hear me. Anyway, so I have an idea that you might have a small, I'm guessing that you all probably have an air compressor that's probably more than 20 horsepower, I would think, but it might not be. It's probably a double screw. It may be oil injected, or if you might need to have clean air, it might be oil free, which is more expensive and way less efficient. Regardless, you're using compressed air. We're going to talk about ways to save in compressed air energy usage. 3 general ways that I've written here. The first is reduce your pressure. You might be chugging along and making air at 100 PSI, and you might not need it. Most of the places I go just say, hey, it was like that when I got here. They're making air at 120 PSI, and I asked them, Well, can you use 100 PSI air? And they say, I don't know. What I always recommend to plant managers, people who have control over that air compressor, is to dial it down 1 or 2 PSI, wait a week, see if anyone complains. Keep doing that until something happens. Hopefully nothing disastrous, but I mean, and then turn it up a couple PSI just to be safe. Most of the places that I've gone to are floored at how much energy savings can be realized by just turning down the pressure. A rule of thumb that I've written here is every 2 PSI drop gives you 1.6% reduction in energy usage. So if you can drop by 10 PSI from 110 down to 100 PSI output, you're going to reduce your compressor energy savings by 8%, which really, again, it surprised a lot of people. So reducing pressure, super easy to do. Reducing leaks, I've written as the novice way to do it. Yeah, I mean, it takes a while to find leaks. It can be difficult to find them. You may need an ultrasonic leak detector, or you might need a specialist to come in and analyze your leaks. There are ways to put a number on the amount of leaks that you have through monitoring power input to your compressors. And that's something we do, at the Industrial Assessment Center. Every assessment we go on to a manufacturing facility, we put these little current transducers on the 3-phase power. One of the leads of the 3-phase power going into the air compressor, we put a current transducer on there and we monitor power usage. Well, we monitor amperage, which is a surrogate for power usage, but we monitor the power usage for a week and we figure out how your compressor is, how loaded it is and how much air it's making. And so if you have a period of downtime and your compressor is making air, then you can pretty easily tell that all the power going to your compressor during that downtime is going to feeding leaks. We have seen, it says in this slide, can account for 40% of total usage. Yeah, that's true. I've seen up to 60 or 70% of all energy going to compressors just going to feeding leaks. I have seen, I don't know why, but compressed air is this area where people just they turn the compressor on, they say, well, we need air. You know, that's what we need. But I've seen air receiver tanks after the compressor and the dryer and the filter. You know, you have this big receiving tank usually. I've seen a blower, a hose with a pressure, you know, a nozzle, and like an 1/8 of an inch hole in that. And this one tiny hole that was just leaking air was wasting this one company thousands of dollars a year. And all they had to do was just repair a hole in a hose. Anyway, I'm not here to bash anybody on poor usage of compressed air. I'm here to tell you how to increase your efficiency. So reducing pressure is easy, leaks maybe more difficult. And you can never really totally eliminate leaks, right? You can only slow them down. So you just got to be kind of vigilant and vigilant. You have to be on top of things. Anyway, more expert levels of reducing compressed air energy usage, which can actually yield a lot of savings, are looking at the specifics of how you're operating things. It says VFD modulation with unloading. Those are just control strategies on the compressor, and sometimes using a different control strategy can really be beneficial. I'm going to stay on time, I promise. Other compressed air best practices is don't use a compressor if you don't need to. Yeah, sure, use it for pistons or pneumatics or whatever, but don't use it as a blower to clean things off if you can avoid it. Compressing air, just FYI, is incredibly inefficient because of how physics works. When you run an air compressor, you're heating up the gas more so than you're doing compression of the gas. Unfortunately, that's just how it works. And so it's about 20% efficient in the end when you get compressed air versus the amount of energy you put into it. 20% efficient. Horrible, I know, but you need compressed air for stuff, so we can't get around it. So don't use it unless you need to. This says avoid short cycling. If you have a load and load compressor and it's kicking on and off a lot, there could be something wrong. You might need more storage in your receiver tank. Short cycling can actually cause damage to your compressor over a long period of time, and also is energy. It's inefficient because Well, because you have to blow out your sump every time you do that. Avoid short cycling if you can. If you can use VFDs, please do. Other best practices for compressed air, use as large, excuse me, as large headers as you can. The bigger the diameter of your headers, the less pressure is lost from compressor to the end use. So that means you can turn down your pressure and save 1.6% for every 2 psi. And this last one, maybe not something that you might be able to directly benefit from, but sometimes the coolant air used to cool compressors can be ducted inside for HVAC purposes, or used to preheat, or used to, I don't know, used as an inlet for an oven or something. If you can use waste heat in general, we recommend that you do, and there's waste heat in compressed air. Anyway, as was with the lighting example, I've got another example for compressed air. If I haven't mentioned it before, we do a very good job at the Industrial Assessment Center in Alabama here with our compressed air energy audits. And this was an example, and it's a pretty neat and unique example. So this facility we went to had a 100 horsepower compressor that was designed to give 450 ACFM, actual cubic feet per minute, at about 110 psi. So they were running along at 110 psi. This thing was operating Monday through Friday, 12 hours a day, every week of the year. So the operating hours was just over 3,000 hours per year. And they turned it off when they went home, which again is something you should always do. Never leave the compressor on to feed leaks on the weekend if you can avoid it. However, in looking at the data we got from analyzing the amperage going into this compressor, we figured out that they were only using 150 cubic feet per minute on average. And that'll become important later. Regardless, by looking at the kilowatts and the kilowatt hours going to this machine, we estimate it was costing them about $21,000 a year to run this 100 horsepower air compressor. So it costs about $21,000 a year to run the compressor, and they use about 1/3 of what the compressor could give them, which doesn't seem that bad. However, control strategies, as I said, is the expert level thing, but it also can give you a good insight of what's going on. It was a modulating control on this compressor. Now, I'm sorry, but this won't be on the test, but the modulating control compressors have a butterfly valve going into the compressor, okay? And this thing, basically, if you need more air, it opens up. If you need less air, it closes down. And it does this to maintain a steady pressure in the system, okay? And so this was 2/3 closed, so to speak. They were at 33% capacity. 150 over 450 is 33% airflow capacity. And so the modulating control, unfortunately, uses a lot of power still, even if you have a low amount of air being used, because there's a big pressure drop across this butterfly valve. And so this is just, in summary, the amount of power they were using was 75%, so 75 horsepower. They were still using 75 horsepower of 100 horsepower to deliver 33% of the capacity. So there's a bunch of other lines in here, but really we're just concerned with this green line, because that's the way this specific compressor was controlled. Now, we went up to, we analyzed the system, and we said, okay, here's 2 recommendations we're going to make for your compressed air system, for your 100 horsepower compressor. We told them to decrease the pressure to 100 psi, which they said they could do because they didn't have any equipment that needed really high pressure. So they decreased their discharge pressure to 100 psi, which saved them yada 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 $1,600 a year and change, which again is something that's very easy for you to do. The second thing, which was really neat, is that they had a control on this compressor that you could literally go up to the control panel and, you know, poke around a little bit and change the control strategy from modulation, which is actually very good because it maintains an incredibly steady pressure by this butterfly valve. We changed it from modulation to load unload. And a load unload strategy, I'll go back to this, has this line right here, this little red line. Okay, so what is load unload strategy? Well, you set a pressure band. It's a lot like your thermostat, but you set a pressure band and the compressor goes on until it hits, for example, 110 PSI, then it shuts off till it goes down to 100, okay? And it goes on and off and on and off. It's not on off because these larger compressors, you don't want to shut them down completely because it's really difficult to get them spinning back up again. So what they do is they just close the inlet valve. Actually, they discharge to ambient. That's what they do. It just loads and unloads. So these screws are either making air to go into the system or they're just blowing air out. Okay, so I'm getting way too deep into the weeds, but all I did was we went up, we changed the control strategy to load unload from modulation. And in doing so, they were able to save another $8,000 a year based on how they controlled their air compressors. And so again, this is maybe an expert or advanced topic in compressed air, but this just goes to show you that there are lots of ways to save energy in your compressed air. Decreasing discharge pressure is huge. Reducing leaks, again, 40, maybe 60% of your cost for your compressor might be going to feeding leaks. So that's something you should look at. And if you can somehow make it to change control strategies to make things easier for you, please do so. Anyway, so total savings for this particular client was $10,000 a year and 43 tons of CO2 savings in emissions per year. The payback was immediate. After we left, they made these changes, and now they're saying an extra $10,000 in their pockets every year. I've got 10 minutes left. We're going to keep going. Refrigeration. I always go slower during actual presentations than in run-throughs. I'm sorry. I'm assuming you all use refrigeration to cool beer and maybe I don't know, chill down the wort at some point in time. Excuse me. And so for refrigeration, a couple of best practices. One, you should always look around to see if you can insulate things. This goes for refrigeration and for heating. I recommend that you all rent a thermal imaging camera and go around, and this is a thermal image of a glycol line, a chilled water line, for example. And just go around with a thermal imaging camera and see if you can spot hot and cold spots. If you see something below 50 Fahrenheit, you should be insulating that, whatever it is. If you see something above 110 Fahrenheit, you should be insulating that because you're going to pay extra costs in natural gas or electricity for your refrigeration to do that. Not only that, but if it's inside, you're also paying to condition the air that you have, this uninsulated line in. So, I mean, anyway, it just goes to insulating is incredibly cheap. And it's a best practice to go around your facility, and this is really low-hanging fruit. You can see immediate savings in this kind of thing. Other points here: service your equipment regularly. Water versus air-cooled chillers. This is a topic I'm not going to talk too much about, but if you can have a water chiller that's attached to a cooling tower, it's going to be like double the efficiency of a water chiller that's cooled via air. The condenser is cooled via air. If you can, here's another best practice. If you can use 85-degree Fahrenheit water to do your cooling in your process, please consider evaporative cooling. What I'm talking about is a cooling tower. The cost to run a cooling tower are substantially less than the cost to run a water chiller that gives you 35 to 40-degree Fahrenheit water. It takes a lot of energy to make water that cold, whereas you could just use evaporative cooling towers to give you very cold water. Well, reasonably cold water. Other best practice here are thermostat setback. If you can set back your thermostat in terms of your HVAC refrigeration system, your air conditioners, please consider doing so. Again, that's easy. Smart thermostats also work very well. I've got another, I'm not going to go into too much detail about this because I want to get through natural gas, but we had this one client we went to go see. They had a broken chiller. It was an air-cooled chiller, and they were renting a chiller for $2,200 a month. And they were spending $44,000 a year for this water chiller, and it was cooling an air compressor. That's beside the point. So we actually went in there and we determined that they didn't need chilled water for the air compressor, they could use evaporative, they could use a cooling tower to do the same thing. And so we said, well, get rid of this thing and install a 50-ton cooling tower. Obviously, it's unlikely any of you need that much cooling capacity, but if you can do things with evaporative cooling, i.e. a cooling tower, please do so. We saved them like 90% in their energy costs. And it was a pretty expensive project, you know, around $50,000, but saved them a lot of money on energy costs for sure. And also this rental fee, which was kind of silly. Please don't rent equipment. If you need it for your process, buy it. Okay, so I'm done bashing these people. Motors, oh gosh, okay, so I haven't left myself a lot of time to talk about motors, but you need motors to run things. You need motors for conveyor belts, fans, pumps, all kinds of stuff. If you have old motors and they break, please consider buying new premium efficiency motors instead of rewinding old motors. A lot of people say, well, you know, it's half the cost to rewind it. Yeah, that's true, but you're just going to get decreased efficiency on an older motor. Then if you buy a new motor, the NEMA is the, shoot, I forget what the acronym is, electric. Anyway, NEMA is the premium efficiency rating for motors. And if you buy a new motor, there has to be a minimum efficiency. You're going to get, if you have a 20 horsepower motor, you're going to get 92% efficiency. I'm ballparking here. I don't know what the exact value is. I have measured directly efficiency of motors in the 70-80% range, and that is terrible for a motor. If you have old motors and you suspect something might be off, it might be time to start thinking about replacing them and start getting saving energy on that. So yeah, consider replacing, turn them off when they're not in use. I mean, that it goes without saying, but I mean, if you have conveyor belts running when there's nothing on the lines, please consider ways to, I don't know, motion sensors, switch, an operator switch, something to shut those down so they're not used when not in use. And the last thing is, if you can use a variable frequency drive, please use it whenever possible. A VFD, or variable frequency drive, it actually controls the frequency of the electricity going into the motor, allowing it to slow down or speed up depending on how fast you want the motor to go. Here's a really neat thing. If you can reduce for a pump or a fan the flow rate or the speed by 50%, there's this thing called the affinity law, see third year mechanical engineering, but anyway, you can reduce the power consumed by 87.5%. So there's a cubic relationship in there, which is pretty powerful. In fact, a quick example for a recent dairy manufacturer using 230 horsepower on a clean in place system. They were running 75 gallons per minute, but they only needed 45 gallons per minute. And so based on this previous affinity law that I was talking about, again, yada, 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 by using a VFD, they could actually, by going from 75 to 45 gallon per minute, they could be using 45% less power. And they already had VFDs in place. And we just told them to put either a control system or just pay someone to go around and check this every couple hours. And they were able to save $13,000 a year on using these motors. So this is all just a big, long, drawn-out example to tell you that if you can use a variable frequency drive to run things at half or quarter speed when you need to, please do so. You can save a lot of energy, and it'll pay for the VFD. They're getting a lot cheaper these days. So, you know, cost savings, 60 tons a year, immediate payback time. This was a win-win. Okay, so I've got I'm going to spend 5 minutes talking about natural gas now. You burn natural gas, okay? We've talked about electricity, lighting, air compressors, refrigeration, motors. Now I'll talk briefly about natural gas, and we can discuss this at more length if you want later. But generally, I'm guessing you all use natural gas to either directly or using steam, boil stuff. I think you probably are boiling, at least what I know about brewing beer, you're probably boiling the wort at some point in time. If not, you're using steam to do stuff. And if so, you should probably get that boiler or the combustion efficiency checked semi-regularly. People will come in and they'll do an emissions test, and they'll do it at full fire, half fire, quarter fire rate. And they'll tell you the percent oxygen, CO2, CO, excess air, all that neat stuff that you need to know how you're doing with natural gas. And they'll actually do a tune-up. So there's like these little linkages, and they'll tune it up so that you're using less excess air than you need to burn. And so, and I don't want to get too into the weeds with this, but you don't want to be using too much excess air, which a marker of which is the percent oxygen at the in the stack gas. Okay. Reason being, if you use too much air, that flame is not going to be as hot, and you're not going to be able to boil water as effectively, because there's too much air going along for the ride. Anyway, common recommendations we have for natural gas are, hey, if you have hot exhaust, maybe you can use that somewhere. You can use that to preheat combustion air. More commonly, you can use that to preheat feed water going into that boiler. Other ways to save electricity: make sure you're returning as much condensate as you can back in your deaering tank, and then back in the boiler eventually. Other ways to save energy: variable frequency drives on the burner fan. You can save electricity and natural gas in that way. And again, if you can insulate any hotspots on the boiler or on your steam system, you're going to save in natural gas energy usage. And I'm not going to spend too much time on natural gas because it involves combustion analysis, but if you can somehow get somebody to analyze the combustion on your water heater or your natural gas, it might be worthwhile. You could be doing things incredibly inefficiently, or you might be doing really well. But it's nice to know if you're doing things well as well. Okay, so I'm about at the 1 hour mark. If you have more questions about natural gas, we can talk about it, but I didn't really spend as much time as I did on electricity. But yeah, I don't know. There's a bunch of stuff on this slide, but yeah, the summary is there could be big opportunities for you to reduce costs. I say think outside the box. If you see waste heat somewhere, there might be a way for you to use that. Without coming into your facility and looking at things, I can't tell you offhand how to do it, but just think outside the box. There might be a way to use, for example, I think that using plate heat exchangers, if possible, might be a good idea, because heat exchange is really important to cool things down quickly and to get as much as you can out of coolant water. But anyway, I'm getting, again, too far into the weeds. Waste heat, turn off equipment if you can. And if you want our help, you can contact me or the UA Industrial Assessment Center. We can do a free assessment on your facility if you fit in those guidelines we talked about earlier. Or if you want some advice on how to use renewables, you have some, if you're brewing beer, you definitely have some possibilities for bioenergy and maybe solar energy as well if you have a roof. Please give us a call and we'll talk. Anyway, thank you for your attention. I have a bunch of links here. Go to those links if you're interested, or email me for more information. So that's it. It's not quite 11, so hopefully you all didn't fall asleep. And if you have any questions, please ask them. Thanks for having me.
Awesome. Hey, thank you so much, Dr. MacPhee, for sharing that information. I know our team took notes, and I know a lot of folks got some great information there. And you're right, some of it's low-hanging fruit and it seems kind of obvious, but you shared some really interesting technical things that a lot of us could start to implement at our facilities. And there were a couple of questions that came through. One of them, a lot of them all kind of tie in together. So I'll wrap it up with that last one. The first one I saw, we'll kick it off with this one. You talked about renting thermal imaging cameras. Are the box stores like Home Depot, or are those good enough? Do you have any recommendations as to brands or things like that?
No, I don't. Okay, well, it's unfortunate I told you to do something and I can't direct you any further than me telling you that. But what I will say is that, okay, so I have my brother-in-law had this like little thermal imager he plugged into his iPhone, and that was good enough. It was like $100, and he was able to spot. You're really just looking for hot and cold spots. The really expensive thermal imaging cameras are the ones that can detect, the 600, 700, 800 degree range. In a brewery, you're really looking for things that are just barely out of your comfort zone. And so you don't need to go expensive for these things at all. I mean, you can buy them if you want. I have heard that, and in some cases, you can actually use thermal imaging cameras, the more expensive ones, to actually detect leaks in compressed air systems. because if you've ever punctured a CO2 canister, it's really cold, right? And so that's just what happens when gas expands. It has to cool down. See the ideal gas laws. But anyway, you can do lots of things with thermal imaging cameras. And I didn't even answer your question. The question was, rent one. If it's a thermal imaging camera, it should do the job. I don't think it matters really which one it is. Just go for the cheapest one you can. As long as it gives you good colorful images, you'll be able to see your problem areas. And if you do see a problem area, you can take direct temperature measurements using like an infrared thermometer that you might put on your kid's head. You know what I mean? Anyway.
No,
that's my answer to your question. Sorry if I didn't answer it fully, but
no,
I don't think it matters.
That sounds good. Whoever sent that in, feel free to put in the chat if that looks like that was good. Another question we got. I'm honestly not sure how to read our utility bills to see if our facility wastes or uses too much energy. Is there a tool we can use to help us read our energy waste? And I know, Dr. MacPhee, we've used in the past the DOE energy tool to help give good information there. Do you have any recommendation as far as reading utility bills?
That is that's a good question. I don't have, okay, so the problem is that every single state and every single power provider is going to be charging you differently on your energy. I will tell you right now that this is a very difficult question to answer, and I don't think that something exists other than the information that I've provided you or taking a course that I teach can help you out very much. For example, if you go up in the northern part of Alabama to the Tennessee Valley Authority, their rates change every month, just based on how they they do things up there. Our rates remain relatively stable down here in Alabama Power Territory. And some places might not have ratchet clauses. Some people might not have a contracted demand, which is another thing I didn't even talk about. Some people, you may have a tiered system, wherein you pay a certain rate for the first 250 kilowatt hours per kilowatt demand. I mean, it's incredibly complicated. And I don't know, other than contacting your power provider directly and saying, hey, someone explain this to me. I don't have any resources to tell you exactly how that's done, because there are literally hundreds, perhaps thousands of ways that over this country, how you might be charged for power. So all I'm saying is that maybe have a look on your demand, on your bill, and see if you can find out whether you are charged for demand or you're charged time of use. An easy low-hanging fruit is looking for power factor excess charges and looking for whether you're charged your measured demand or whether you're charged on the ratchet clause, which is 90% of the peak of the last 12 months. Okay. If you are, if you qualify for Industrial Assessment Center services, obviously we'll look at all these bills for you free of charge. But other than that, I'm talking way too much about this, but I would just recommend that you all just talk to your power provider. They will explain it in more detail than I can in this amount of time.
No, I thought that was great. And I think you answered it fully, and it really leads perfectly into the very last question is, how can our facility go about getting the IAAC, so the Industrial Assessment Center, to come out to our brew house? So again, I've put contact information, but David, will you go over kind of the parameters to get your group to partner up with some of these?
Yeah. So again, it's this awesome program where we have undergrads working for us and grad students and several faculty members. And the first process is just going to our website. I mean, you can email me at that email right there, and I'll point you to the website. Alternatively, you can just go directly to the website, which is iac.ua.edu. You know what? There's a chat here. Let me see if I can do this. Send to everyone a meeting. iac.ua.edu. There we go. There's the website. I'm going to test it and make sure it works. Hooray, it works. Okay. So go to that, and if you spend over $100,000 a year, I mean, we can go a little bit underneath that, but not too far underneath. The reason being is that the Department of Energy wants us to have a meaningful impact on every trip that we make. So if you spend over $100K a year on energy, you're big enough for them to worry about And if you spend over $2.5 million a year in energy, you're too big, and you can probably afford your own engineer to do that full time, right? And so that's why we have this little sweet spot here. So if you go to this website and just go to apply online, there's a tab right there. You enter in. You don't have to have all this information. This is all just stuff that if you have this information handy, great. If not, just put in whatever you can think off the top of your head and submit it, and then we'll get back to you. The way the process works is we need a year's worth of electricity and natural gas bills and a brief outline of what you do. And then we'll schedule a visit where we come down there and spend, during this pandemic, we're spending a little less time at the plants, but we'll probably be there for 6-7 hours collecting information and discussing your plant specifics. And then, we leave, we come back to Alabama. Sorry, we come back to Tuscaloosa, put our thinking caps on, and we take about 60 days to produce a very high quality, it's like a 100-page report. But there's like a table in the very front that has everything. So you don't have to read the 100 pages. They're all engineering calculations. Long story short, go to that website and apply online, and we'll get back to you and determine whether you're eligible, and we'll take it from there.
Awesome. Awesome. And if I could tie that up in a little bow, if you find that you're not eligible for the IAC services, please contact either Michael Raspberry or myself, because the team at UA SafeState would be happy to help advise as well. So hopefully everybody here is included in one of those two categories. Either way, you have a resource, and our contact information is up on the screen if you do want to learn more or have questions about other pollution prevention strategies. So with that, Dr. David, we honor your time, and we honor everybody else's time that's on the call today. So again, we appreciate everybody for joining us. Please do not hesitate to contact our teams for assistance. You actually see on the screen now the website for UA SafeState. And our promise to you is that we plan to make our P2 webpage live soon, where this webinar, along with others, including the one that we hosted yesterday about wastewater, will be listed and serve as an educational resource and a tool for your business. So with that, we will close out today's session. Thank you all so much for attending. Get back to making great beer. It'll be 5 o'clock soon, so I hope to enjoy one then. I hope everybody stays safe and has a great day.
Thanks, Ashley.
Thanks, everyone.